Good afternoon, class. I want us to continue what we were teaching last week. Next week, I will not be around. I will go to Science Resource Center to arrange some practicals for you, because we are not having enough apparatus in our school, as you are aware. So due to that, I want you to use this video in my absence. I gave you this trial work when we started Ohm's Law. The circuit was something like this. Two volts here, 1 ohm, 3 ohms, and then this one is 2 ohms. I said you should find I. Before you go through this work, you are supposed to find effective resistance. As you are aware, you know that Ohm's law V is equal to IR. So your I will be equal to V over R. And this R we have here is effective resistance or total resistance in the whole circuit. Circuit on the board, you want to solve it. This was your trial work. Ohm's law V is equal to IR and I is equal to V over R. And your R is the effective resistance, that is the total resistance in this circuit. And you can see that 2 ohm is parallel to 3 ohm resistor here. We solve this, and 3 ohms are in parallel together in series to 1 ohm resistor. So first, let's find what we have here first. We have 1 over 2 plus 1 over 3. So as you can see, 1 over R will be equal to 1 over 2 plus 1 over 3. 1 over R will be equal to, if we simplify this fraction we have here, then we are going to have 3 plus 2 over 6, which will give you 5 over 6. And if you solve from R, solve for R in this equation, you have R will be equal to 6 over 5 ohms. Then this 6 over 5 ohm is in series to 1 ohm resistor. So R effective resistance in this circuit will be equal to 6 over 5 plus 1. And if we simplify what we have here, then we have 11 over 5 ohms. That is the effective resistance in this circuit. From Ohm's law, I is equal to V over R. The V as the voltage given in the circuit is 2. I is equal to V over R. V is 2, that is the voltage in the circuit, 2 over R, effective resistance, which is 11 over 5. And when you simplify this fraction, then you have 10 over 11 amperes. So that is the current circulating in this circuit. Those who couldn't get it correct, you do the correction. And whatever problem that you have, when you meet in the following week, then you ask any question at all that you want to ask. Now, today, we are going to look at experimental verification of Ohm's law. Experimental verification of Ohm's law. And we are going to follow this circuit. Good. Going to look at experimental verification of Ohm's law. Apparatus we are going to use is what you see on the bench. You have standard resistor, which is here. You have voltmeter. This one is digital voltmeter. Then we have the analog ammeter. We have ammeter. We have the key, power supply, and then we have 6 connecting wires. 6 connecting wires. So we are going to connect this, and after that we use it to verify Ohm's law.
Master.
Introduce the apparatus we are going to use to verify Ohm's law to you. Have voltmeter, resistance box, ammeter, key, the ticket key inside anyway, ticket key. Then we are going to use 6 connecting wires plus power supply, which is set to 3 volts. 3 volts power supply. So we are going to follow the circuit on the board. We do the connection. Now, if you check the power supply that's as we are going to connect the apparatus we have here, just like what you see on the board, the circuit on the board. So we connect the positive terminal of the power supply, as the black spot. Connect it to the key. Then from the key to the standard the resistance box. Key, then it move on to the resistance box. From the key to the resistance box. Then from the resistance box, let's connect this one first to the ammeter. So from the resistance box to the ammeter here to the ammeter. It will be connected to the positive terminal. Then from the ammeter to the power supply, which is supposed to be from the negative terminal. Sorry, here is supposed to be to the positive terminal. This one to the positive terminal. And from the negative terminal of the ammeter to the power supply. Then we take our voltmeter and we connect it. We connect it parallel to the resistance box. Now let's try and see if everything is correct. So if I switch this one on and I close the key, okay, let me switch on this. It's now working perfect. You are going to use resistance 1 ohm, 2 ohm, 3 ohm up to 4 ohms. So I draw my table this way. R ohms, voltmeter, and then ammeter. So I use 1 ohm, 2 ohms, 3 ohms, 4 ohms, up to 5 ohms. Right. let us continue. Resistance bus, if I remove 1 from the resistance bus, it means we are using 1 ohm resistor. Let's first switch on the key. It means I have removed 1 ohm resistor. When I removed 1 ohm resistor, the current is now 1.678, 1.8. Let me send it to 2 decimal place. 1.80, and the voltmeter is 2.15. This was late in quite a digital 2.15. That is when I remove 1 ohm resistor from it. Now let me put it back. This time round, let me take 2. And I take 2 ohm. Let's see what will happen. Our power supply is giving us problem. So when I take 2 ohm, let me record what we have here. The voltmeter is now 2.41. 2.1, and then the current is also 1.05, almost 1.05 amperes. That is when I take 2 ohm resistor. This time, well, let me take 3, 1 and then 2. Now let's record what we have here. 2.60, 2.60, and then the ammeter read 0.7, 0.7, yeah, exactly 0.70. This time let me take 4, 2 and 2. Then the voltmeter read 2.66, and then the ammeter also read 0.65. Alright, let's move on. So from 4, then we are going to take 5, so we add 1. The voltmeter read 2.72, and then the ammeter also recorded 0.40. So these are the results we have on the board. The moment you finish, you put the key, then you switch off the power supply. Let's analyze our values and see if our values verifies Ohm's law. You know, Ohm's law V is equal to IR. It tells us that current I is equal to V over R. So, if we increase the resistance, it means we are expecting the current also to decrease. Increasing resistance, decreasing current. That is what we see on the board. When we are increasing the resistance, 1, 2, 3, you see that the current recorded also decreases as the resistance is increasing. This is a mathematical equation, and because the voltage is also directly proportional to the resistance. As the resistance also increasing, the voltage also increasing. As direct variation, as you can see, this value that we have got from our setup verifies Ohm's law. So, I want you to continue by plotting a graph. I want you to plot a graph of V against current. When we meet again in our next meeting, we shall discuss the graph that we have plotted. Thank you very much, and I hope you make good use of the time in my absence. We install the lab technicians to provide you all the setup, and we make sure you follow the instructions as to be given to you. Thank you very much.